Good morning, students. All last class electromagnetic waves is completed. Now we will start the new lesson, ray optics. Okay. Name of the chapter will be ray optics. It is a big chapter and totally 6 main concepts here we will discuss. What are that concepts is, first one will be reflection at plane surfaces. Next, reflection at curved surfaces. Okay. Next, refraction at plane surfaces. Next, prism. Next, refraction at curved surfaces. Next, optical instruments. So these are the main concepts we will discuss in this chapter. One by one, what are the formulas are there in this we will discuss. Okay. First of all, if you will discuss about reflection at the plane surfaces. Before that, light is an electromagnetic wave. Velocity of light in vacuum C is equal to 1 by square root of mu naught epsilon naught. That is the formula. Next, velocity of light in a medium C medium is equal to 1 by square root of mu epsilon. Okay, this is the formula for velocity of light in the medium. This is the velocity of light in vacuum. Now we will discuss about the reflection at the plane surfaces, means reflection at the plane mirrors. What formulas we will use, we will discuss about it. Okay. First of all, reflection. At plane surfaces. So in this, first formula will be, if this is the mirror, if light is incident like this, light is refracted like this, this is angle of incidence, this is angle of reflection. Angle of incidence value will be equal to angle of reflection. Angle I is equal to angle R. Next, second one, what is the deviation produced by the light ray means 180 minus 2i. So if the mirror is not there, this light ray will comes like this. Because of this mirror, light ray came like this. This angle will be called deviation. Because R is equal to I, this total value will be equal to 2i. This line total angle will be 180 degrees. So this angle will be equal to 180 minus 2i. Okay. Next, some applications we will discuss in this. For example, here one mirror is there. A person is there. He is moving towards the mirror with velocity v. A person is moving towards the mirror with velocity v. What is the velocity of the image? In the mirror, they will ask velocity of image will also be equal to velocity of object. So that will be equal to V. What is the relative velocity of the image with respect to object? Like that questions will be there. So relative velocity of image with respect to object, that will be equal to 2V. Okay. Next, a person is there. What is the minimum height of the mirror to see the full image of a person? Minimum height of mirror to see full image of a person of height L is H is equal to L by 2. For all of these proofs are there. No need for all of that proofs. Just remember them as the formulas. For example, a person is having a height of 6 feet. How much feet of mirror will be required to see his full image means 6 by 2, that will be equal to 3 feet. For example, another formula will be there. Here, a person is there in a room. A person is, this is a room. A person is at the center of the room. In front of him, one wall is there. Back side, one wall is there. To this wall, one mirror is attached like this. To see the full image of the wall, which is his back side. For example, the length of this wall will be L. To see the full image of the wall, which is back side of him, he is facing towards the mirror. Their mirror is there. I am looking like this. To see my back wall completely, what is the minimum height of the mirror means this value will be equal to L by 3. So, height of the mirror required to see the full image of the back wall when a person is standing at the, or when a person is there at the center of a big room will be L by 3. Okay. Like this, some theoretical questions will be there. Next. Two mirrors are arranged with some angle. How many images will be formed? Like that, questions will be there. For example, two mirrors are inclined like this. Here, what is the angle between the two mirrors? 90 degrees. If theta is the angle between the two mirrors, in between them somewhere one object is placed. How many images will be formed? Like that, questions will be there. So for that, first one, if theta is the angle between two mirrors and 360 by theta is an even number. Here angle will be 90 degrees. 360 by 90 will be how much? 4. Angle between them is 60 degrees. 360 by 60 will be how much? 6. That is even. If 360 theta is the angle between the two mirrors, 360 by theta is an even number. I am assuming this is equal to m. Then number of images formed will be equal to m minus 1. Understanding? So how many images will be formed means m minus 1. Next, m is equal to 360 by theta is an odd number. Then n is equal to m if object is not on the bisector. N is equal to m minus 1 if object is on the bisector. What is the meaning of this? See, two mirrors are there like this. This is the bisector. This is one mirror, this is another mirror. Here one object is there. For example, angle between the two mirrors is 40 degrees. 360 by 40 will be 9. So, if 360 by theta is an odd number and object is on the bisector, how many images will be formed means m. If not on the, it is not on the bisector, m. If it is on the bisector, then how many images will be formed means m minus 1. Understanding? Like this questions will be there. If 360 by theta is not an integer, it is a fraction. If m is equal to 360 by theta is a fraction, then n is equal to m, integer part we had to take. What is the meaning of this? For example, angle between the two mirrors is 50 degrees. Okay. Then 360 by 50. How much this will be? 5 7s 35. So 7.2. Then how many images will be formed in the mirrors means this integer part you have to take. 7 images will be formed. Like this questions will be there on the plane mirrors. Okay. Next, and one more. If the mirror is rotated by an angle theta, if mirror is rotated by an angle theta, then reflected ray rotates by an angle 2 theta. So many times this condition we will use in the problems. For example, here one mirror is there. One light ray is incident like this. Since normal incidence, in the same path light ray will reflect. Okay. I rotated this mirror by an angle theta. Like this I rotated. Initially mirror is like this. I rotated the mirror by an angle theta. Then light incidented like this in the same manner. This will be the reflected ray. Actually initial reflected ray will be like this. Na? In this case, this is the reflected ray. Reflected ray comes like this. This angle will be equal to 2 theta. This angle will be theta. This angle will be theta. So, if the mirror is rotated by an angle theta, reflected ray will rotate by an angle 2 theta. Actually, reflected ray is like this. When mirror is rotated, it is coming like this. This angle will be equal to 2 theta. Okay, so these are the formulas related to plane mirrors. Next, second one, reflection at spherical surfaces. Just two types of spherical mirrors will be there. One will be convex mirror and another one will be concave mirror. Only two formulas will be there. F is equal to R by 2. Relation between focal length and radius of curvature. And mirror formula 1 by F is equal to 1 by U plus 1 by V. Either it is a concave mirror or convex mirror, you have to use this as the mirror formula. F is the focal length, U will be object distance, V will be image distance. Only these two formulas are enough. This year, because of this corona impact, mirrors are completely removed in the CET. Both in the reflection at the plane surfaces, reflection at the curved surfaces are removed in the CET. If you are preparing for the NEET, you have to prepare this one. No sir, if I will only concentrate on the CET means just neglect these two parts, reflection at the plane surface, reflection at the curved surfaces. Next, third one will be refraction at the plane surfaces. Refraction at plane surfaces. So in this, first of all, absolute refractive index will come. Absolute refractive index mu is equal to velocity of light in vacuum by velocity of light in medium. This is the formula for absolute refractive index. Okay. Next, so this value will be equal to 1 by root of mu naught epsilon naught. This value is equal to 1 by root of mu epsilon. So finally this value will be equal to square root of mu epsilon by mu naught epsilon naught. Mu means mu naught mu r, epsilon means epsilon naught epsilon r. When mu naught epsilon naught are cancelled, it becomes mu r epsilon r. So absolute refractive index formula C by V or root of mu r epsilon r. Next, when light ray is going from rarer medium to denser medium, this is rarer medium, this is denser medium, this is the normal. When a light ray is going from rarer medium to denser medium, it will bend towards the normal. So, when light ray goes from rarer to denser medium, it bends towards the normal. So in this case, I value will be greater than R. What is the deviation means? I minus R. When light ray is going from denser to rarer medium, when light ray is going from denser to rarer medium. It bends away from the normal. Okay. In this case, I value will be less than or deviation value is equal to R minus Im. This is the denser medium. This is the rarer medium. Light ray comes like this. This is I and this value will be R. Next. Here relative refractive index will come. Snell's law will come first. We will discuss what are the formulas on that. Snell's law. When a light ray is going from one medium to another medium, this is I, this is R. This is theta 1, this is theta 2. Then refractive index of this medium is mu1. Refractive index of this medium will be mu2. Then Snell is saying mu1 sin theta 1 is equal to mu2 sin theta 2. This is Snell's law. In vector form, mu1 into I cap cross n cap is equal to mu2 into R cross cap n cap. N cap is the unit vector perpendicular to the plane. These formulas we will use in the vector form of Snell's law. Okay. Next, relative refractive index. Mu is equal to V2 by V1. Refractive index of the second medium with respect to the first medium. Here see mu21 is equal to mu2 by mu1. This will be C by V2 by C by V1. So this is V1 by V2, not V2 by V1. Mu21 is equal to V1 by V2. This is lambda 1 by lambda 2. In refraction, frequency will remain constant. Means a red colored light entered from one medium to another medium. When entered into the another medium, light will appear as the red color only. So frequency will remain constant. Wavelength will changes. Okay. Here lateral shift and normal shift will come. What are that? See. For example, here one glass slab is there. Thickness of the glass slab is T. One light ray is incident in this format. This is the normal drawn here. Then it will bend like this. This angle will be angle of refraction R and it will goes like this. Okay. Then if this glass slab is not there, this light ray will travel like this. These two will be parallel. So like this. Because of this glass slab, this light ray came like this. This perpendicular distance will be called lateral shift. If the light ray is not bent at the refracting surface and already bent refracted ray, the perpendicular distance between those two will be called as the lateral shift. Formula for the lateral shift will be T into sin I minus R by cos R. This formula we will use. T is the thickness of the glass slab. Next, normal shift problems will be there. Here two types of normal shifts will be there. First one will be object is in the rarer medium or denser medium. Observer is in the rarer medium. Here water is there in a bottle, in a tank. At the bottom of the tank one coin is there. For example, we are observing the coin from air. So here observer is in the rarer medium, object will be in the denser medium. Then object will comes closer than the distance. So it will appear like this. Or here observer is there, he is in the air but closer to the surface. So then this will be the real distance. This will be the apparent distance. Calculate that apparent distance, like that questions will be there. So first one, when object is in denser medium and observer is in rarer medium, object appears closer. So what is the formula here is mu is equal to real distance by apparent distance. But remember, mu value will be always greater than 1. If it is apparent distance by real distance, that value ratio will be less than 1. Like that you can remember. Mu is equal to real distance, real depth by apparent depth. Okay. What is the shift? So real depth minus apparent depth. So real depth minus RD by mu from this. So RD real depth into 1 minus 1 by mu will be the formula for calculating the shift. Next, when object is in rarer medium and observer is in denser medium, at that time object appears farer. At that time mu is equal to apparent depth by apparent height or apparent depth by real depth, apparent distance by real distance. Shift is equal to apparent distance minus real distance. So this will be mu minus 1 into real distance. These formulas we will use in that case. Okay. So next here critical angle will come. Critical angle means what? Light is going from denser medium to rarer medium for a particular angle of incidence. Angle of refraction will be 90 degrees. That angle of incidence will be called as the critical angle. So here this medium refractive index is 1 mu. This medium, rarer medium, generally we will consider it as air. So mu into sin C is equal to 1 into sin 90. So mu is equal to 1 by sin C. If this medium is not air, okay, so this medium refractive index mu1, this medium refractive index mu2, if we assume mu2 sin C is equal to mu1 into sin 90, mu2 by mu1 is equal to 1 by sin C. So mu21 is equal to 1 by sin C. These formulas we will use there. Okay. Next, after finishing of this, here one more will be there. A fish is there. Here water is there. Here one fish is there. How much it will look like this? This portion area, how much? How much area on the surface this fish can look? Like that questions will be there. This depth is h. This radius is r. Find that r. Like that questions will be there. This angle will be critical angle. This angle will be critical angle. That radius value r is equal to h tan c, or h is by square root of mu square minus 1. Using these formulas, we will find the radius of the circular part that the fish can view. We can calculate. Or here we kept one bulb. Some circular portion will be illuminated on the surface. What is the radius of that circular portion? They will ask. Then we have to use this formula. R is equal to h by square root of mu square minus 1. H will be the depth of that bulb from the surface of water. Okay. These formulas are enough relating to the refraction at the plane surfaces. Next, fourth one will be prism. So prism will be like this. Already derivation you prepared very well in theoretical exams. This will be I1, this is R1, this is R2, this is I2. This is the angle of the prism. Refractive index of the prism, mu is equal to sine of A plus dm by 2 by sine A by 2 when prism is in the minimum deviation position. Minimum deviation position means this refracted ray is parallel to base of the prism. We can call that prism is in the minimum deviation position. In minimum deviation position, mu is equal to sine of A plus dm by 2 by sine A by 2. This formula we will use. Here prism is not in the minimum deviation position. Relation between I1 and I2, angle of the prism and angle of deviation is I1 plus I2 is equal to A plus D, and A value will be equal to R1 plus R2. Like this problem, in the minimum deviation position, A is equal to 2R, and here I is equal to A plus capital dm by 2. These formulas we will use here. And here some special cases will be there. Normal incidence and grazing emergence. Grazing incidence and grazing emergence. What formulas we have to use? See. Normal incidence and grazing emergence means prism is like this. Light ray is incident like this and it came like this. This will be normal incidence, grazing emergence. In this case, I1, R1 values will be equal to 0. I2 value will be equal to 90 degrees. R2 value will be equal to C. Because A is equal to R1 plus R2. R1 0, na? So R2 value will be equal to A. These formulas we will use in normal incidence and grazing emergence. Next, grazing incidence and grazing emergence means light ray incidented like this, refracted like this. In this case, I1, I2 values will be equal to 90 degrees. Okay, and R1, R2 values are equal, that is equal to C. A value is equal to 2C. These formulas we will use for grazing incidence and grazing emergence. Next, after finishing of this, here angular dispersion will come relating to the prisms. When white light is incident on the prism, it will divides into 9 colors. Which color will 7 colors? 1, 2, 3, 4, 5, 6, 7. This is violet, this is red. So here angular dispersion. Theta is equal to dV minus dr. Next, dispersive power. Omega is equal to theta by dy. Yellow color. So this theta value dV minus dr. This value dV, dy value will be average of dV plus dr by 2. This is mu v minus mu r by mu y minus 1. Using this formula, we can calculate the dispersive power of a prism. Okay. Next, and some more formulas will be there. Condition for deviation without dispersion is, condition for deviation without dispersion is, so two prisms if we arranged like this. So this is one prism, this is one prism. This is A, this is A dash. Its refractive index mu, its refractive index mu dash. Then net deviation, net dispersion will be equal to 0. So this value mu v minus mu r into A plus mu v dash minus mu r dash into A dash, we will use these formulas. Next condition for dispersion without deviation. So d plus d dash is equal to 0, mu minus 1 into a, mu dash minus 1 into a dash. This is equal to 0. This condition we will use for dispersion without deviation. This condition we will use for deviation without dispersion. Okay. Next, after finishing of this, next topic will be, this is about the prisms. Next topic, refraction at the spherical surfaces. Refraction at the spherical surfaces. What formulas we will use here? So here one surface is like this. One light ray incident like this and reflected like this. This medium refractive index mu1. This medium mu1, this medium refractive index mu2. Then this is object distance. This will be image distance. Here what is the formula here is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This formula we will use. Next, second one, lens formula will come. 1 by f is equal to 1 by v minus 1 by u. Next, lens maker's formula. 1 by f is equal to mu minus 1 into, for convex lens I am writing mu minus 1 into 1 by r1 plus 1 by r2. That will be lens maker's formula. Next, here power will come. Power P is equal to 1 by F. Next. If two lenses are kept in contact having focal length f1 and f2, equivalent focal length will be 1 by f1 plus f2. Equivalent power will be P1 plus P2. If two lenses are separated by some distance, focal lengths are f1, f2. Equivalent focal length will be 1 by f1 plus 1 by f2 minus d by f1, f2. Here power P is equal to P1 plus P2 minus d P1 P2. These formulas we will use here. Next, last topic will be optical instruments. Optical instruments. In this, first one will be simple microscope. Totally three will be there: simple microscope, compound microscope, astronomical telescope. In all of that, when image is formed at near point, what is the magnification formula? When the image is formed at far point, what is the magnification formula? Those are enough. Image is formed at the near point. Magnification formula 1 plus d by f. Image is formed at the far point, infinity. This value will be equal to d by f. Next, if you take compound microscope, for this, when image is formed at the near point, minus VO by UO into 1 plus D by FE, so minus L by FO into 1 plus D by FE. These formulas we will use. Here this is minus VO by UO into D by FE or minus LD by FO FE. These formulas we will use in the compound microscope. Next, third one will be astronomical telescope. In this, when image is formed at the near point, minus, what are the formulas we will use is minus FO by FE plus 1 plus FE by D. This formula plus and here L value will be equal to here length of the telescope is equal to UE plus, right, like this, FO plus UE. Next, M infinity means image is formed at far point. This in minus FO by FE. Length of the telescope FO plus FE. These formulas are enough relating to this chapter, and we'll do some problems in this in the next session. Okay, we'll stop this one now. Okay, thank you.